Okay, 2.6 rational expressions. Well, rational might be a weird term for a lot of you. It's a fancy word for fractions. So we're going to do a lot of fractions in this section. We're going to do powers with fractions in them. We're going to do equations with fractions in them and that have x's in the fractions, and we're going to solve them. So that's kind of the whole idea of 2.6. So let's start with the powers, or the roots. Now, we may have not seen something to the fraction of a power, but in order to understand what that is, for starters, we have seen a square root. We've seen, I believe, a cube root, but we can have a fourth root, a fifth root, a 20th root if we want to. All of those are possibilities. So instead of writing all of those out, we just say, sometimes let's take the nth root of something. And so that would just be a square root with an n above of some sort of number. Now we can translate that to say, okay, well, sometimes it's good to leave it as the root, especially if we're dealing with nice whole numbers. Great, let's solve it like that. But sometimes there's an advantage to writing it as a rational root, having a fraction in the power. And so the equivalence is that if I have an nth root, square root with an n on top of a number, that is equal to a to the 1 over n. So cube root would be a to the 1 over 3. A fifth root would be a to the 1 over 5th, so on and so forth. So to see it in practice, I have a to the 1/3. Well, we just learned about rational roots, so it's kind of hard to solve it like that. So instead, let's translate that into something that might look a little bit more familiar. A cube root. Well, a cube root of 8 is 2. There's my answer. Now for this next problem, we have a couple more things going on. So we're actually going to, instead of immediately translating to a root, because then it'll be kind of hard to keep track of things, we're going to take that 1/3 power, we're going to leave it as a fraction, and we're going to distribute it to each of the powers inside that parentheses. So negative 27 will become negative 27 to the 1/3. Now be careful, don't multiply it by 1/3. You multiply the power by 1/3. So it was originally negative 27 to the first. Now it's negative 27 to the 1/3. And I take my z to the 9th, I multiply the power 9 times 1/3, I get 9 over 3. And now I can simplify that z to just become z to the 3rd, which is great. I don't have to take the root and then try to undo the power somehow. And I am going to translate that 1/3 into a root, so I can take the cube root of negative 27. And then the cube root of negative 27 is 3. So I get my final answer of negative 3 z to the 3rd. We don't only have to deal with fractions that are, say, 1 over 5 or 1 over n. We could have any fraction as a power, so we'll want to be able to translate that as well. So I have a to the m over n is equal to the nth root of a to the m is also equal to a to the m taken the nth root. Now we usually deal with the first translation because it's easier to make something small and then big versus make something big and then small, but they're all equivalent. So to see that in practice, right here I have a to the 4/3. Well, I'm going to translate that into a root. I'm going to translate it into that middle definition. So I will get the cube root of 8 to the 4th power. And well, we already saw on the last side that the cube root of 8 is 2. And so it becomes 2 to the 4th, which is 16. Same concept here. I'm going to translate this as my very first step. I'm going to change it into that middle notation. Well, 5 over 2 is going to give me a square root of 9/16 to the 5th. And now if you're taking the square root of the fraction, that's the same thing as taking the square root of the numerator and the square root of the denominator separately. So I'm going to do that. Square root of 9 is 3. Square root of 16 is 4. So I'm left with 3/4 to the 5th power. And then again, I can multiply, or I can take a power to both individual terms separately. So I get 3 to the 5th over 4 to the 5th, and then I probably need a calculator at this point. I guess I wrote it twice. A calculator at this point to actually calculate. It becomes 243 over 1024. I can't simplify that. I know that because I worked out this example before. You should always try to simplify fractions, but this fraction in particular cannot be simplified further. So that is my final answer. Okay, negative exponents. The definition of a negative exponent is really just saying whatever I have an exponential to a certain power, if that power is negative, I move it to the opposite side of the fraction. So if it's a whole number, it will move to the bottom of the fraction. and become positive. If it's on the bottom of the fraction already and it's a negative exponent, we would move it to the top of the fraction and it would become positive. So to see that in practice, I have a to the negative 4/3. I would move that to the bottom of the fraction, and then I've actually translated it in one step. I probably should have done it in 2 steps. So then my power becomes positive, and that translates to the cube root of 8 to the 4th power. Well, we've already seen that before on the previous slide. I take the cube root of 8, I get 2. 2 to the 4th, I get 1/16. Here's kind of a good table of all of the rules that you might need anytime you're seeing an exponential. Yes, ideally, these are going to be a bit of a review for you. Really, the important ones glancing at this are we want to be able to do the product rule, produce rule, it's product rule. I want to do the product rule, saying I can multiply exponentials and add the powers. That's also going to become very helpful later. And I want to be able to use the quotient rule, which says I can divide them. If I divide exponentials, I subtract the powers. And then the last couple are the very last one we've already talked about, negative exponent we just talked about, and then the 0 exponent is anytime you take anything to the 0th power, you get 1. I don't know if we've talked about that, but it could be anything. It could be 1,000,000, it could be a bunch of weird variables flying around. Anything to the 0 power will get you a result of 1. So this isn't a bad idea to maybe take a screenshot of, or do something so you can reference it later in your notes or something, because this is the summary of everything you ideally will know about exponentials. So with that in mind, this is an example of the first rule, the fact that if we're multiplying exponentials, we add the power. So I had x to the 3/5 times x to the 1/4. Well, that's the same thing as x to the 3/5 plus 1/4. And then I have to do a little bit of, maybe this might be a review for hopefully most of you. I have to add the fraction. So in order to add fractions, I get a common denominator of 20. I would multiply the first fraction top and bottom by 4, the second fraction top and bottom by 5. I get those 12/20 plus 5/20. I add them together, which means I only add the numerator, and I get 17/20. And just to note, as a general strategy, this is a good way to kind of approach problems that have a lot of things going on. Is, let's say you get to this point and you say, okay, I have to add fractions. Do I have to keep kind of following a nice sequence of order of things? Well, you can do it off to the side and say, okay, I'm going to pause here. I don't want to make a big mess of my actual worked out solution. So I'm going to add my fractions over here. And then once I found my 17/20, I go back to my question and just write it under that. We're going to move on to factoring equations, and this is kind of a little bit similar to what we saw in our very first section, but it's really going to maybe focus on more so these rules that we just learned. And so when you're factoring and you see two terms, it's generally a good idea, it's generally almost always a good idea when you're solving with factoring to get 0 on one side and all of the numbers and variables on the other side. So our first step is we're going to subtract x minus 3, or subtract x to the 1/3 from both sides, leaving 0 on one side and leaving that expression that we have on the left. But that's not super solvable. So instead we're going to say, okay, well, I don't want to deal with x to the 1/3. I want to factor that out. And I'm going to factor that out of both of my terms. So in order to factor it out of both of your terms, we have to divide both terms by x to the 1/3. And then we're going to move it to the front of those two factors. So this is actually kind of similar to factor by grouping that we saw before, of we're going to divide both terms by this thing that we're going to factor, and then we're going to put the factor in front. So x to the 1/3 divided by x to the 1/3 is just 1, and x to the 5/6 divided by x to the 1/3 is that subtraction. So again, we're going to have to subtract two fractions. We're going to subtract the power of 5/6 by 1/3. And in this case, the common denominator is 6, so 1/3 would become 2/6. I subtract the 2, I would get 3/6, and I get a result of 1/2. So then I can rewrite my whole expression. I have x to the 1/3 in front. My first term is now 2x to the 1/2, and my second term is 1. X to the 1/3 divided by x to the 1/3 is 1. And now I can go ahead and solve this equation. I'm going to set each part equal to 0 and solve. the first equation, x to the 1/3, is pretty solvable. I would just cube both sides and get 0. My second equation, I would have to subtract 1 from both sides, divide 2 from both sides, and we know that x to the 1/2 is the square root. So now we're going to square both sides, and I will get x is equal to the 1/4. By the way, it was worth mentioning, x to the 1/3 is the cube root, and so that's why on the very bottom left of this slide, we cube both sides. Now, moving outside of all of those exponential rules, we're going to go into solving specifically the most often used radical, which is the square root. And so if we're solving with a problem with the square root, we want to, for starters, get the square root by itself. That's already happening in this equation. So my next step is to undo that square root. To undo a square root, you square both sides. So I'm going to square both sides. I get rid of my square root on the left side. 2 squared becomes 4. And then I just go ahead and solve through. This is a 2-step equation, kind of a simple equation to solve. I add 2 to both sides. I divide both sides by 3. I get x is equal to 2. Now, if we're dealing with square roots, this is the first time in the class where it no longer becomes oh, this is a good idea to check your answers, and now it becomes very much you have to check your answers, because you can do everything right, everything can be perfectly fine, and then your answer could still not work. Maybe it's the second time we've talked about that. Anyway, so we need to take our x equals 2 and plug it back into the original equation. We do that by plugging into 3 times 2 is equal to 6, minus 2 gets me 4, square root of 4 is 2. So I see that both sides of the equation are equal to each other. So notice how in the checking thing, I'm not going to be moving things on other sides of the equation. I'm just simplifying each side to see if those are equal to each other. In this case, they are. If I get an answer that doesn't work, I don't include it in my solution. If all of my answers don't work, we say that there is no solution, and the answers that didn't work were extraneous is the fancy word. If you want to write it, I'm perfectly fine with you just taking an equal sign and putting a slash through it. To move on to a little bit more difficult of a problem, same starting point. I want to get the square root by itself. Well, fortunate again, that's already happening. So I'm going to square both sides, get rid of the square root. Now we have to be careful on the right side. That does not become x squared minus 4 squared. We have to write out the term twice and FOIL it out. So the left side's, the square root's going to cancel. The right side, if I FOIL out x minus 4 times x minus 4, it becomes x squared minus 8x plus 16. That one I kind of skipped a few steps as far as foiling goes, but that's all I was doing. That's kind of all that's missing in between those steps. If you don't feel comfortable with that jump, FOIL x minus 4 times x minus 4, and ideally you will get what I have on that right side, x squared minus 8x plus 16. Well, now this is a question very similar to the first section. I have a squared, I have an x, I have a regular term. I'm going to move everything on one side and get a 0 on the other side. So I started by subtracting 16 from both sides, 16's go away. Next I subtracted x from both sides, so I got x squared minus 9x. Now I'm going to factor out an x out of both of those terms, kind of something similar to what we saw 2 slides ago. This one's a little bit simpler because we don't have a rational root, but same concept. I'm going to divide x from both terms and put it in front, so I get my x in front of my 2 terms, and x squared divided by x is x. 9x divided by x is 9. I'm going to set both terms equal to 0 and solve. Well, the first one's a freebie, x is equal to 0. Second one is x minus 9 is equal to 0. I'm going to add 9 to both sides, so I get x is equal to 9. Now, I need to go back and check both of these solutions. So for starters, I'm going to check x is equal to 9. Well, I plug it back into the very first step of my problem. I don't do it any time later when I've done solving because maybe I made an error. So I go back to that very first equation that has a square root. I plug in 9 to both sides. Right side becomes 5. Left side becomes square root of 25, 16 plus 9. I square root the 25. I'll get 5 is equal to 5. Great, my answer worked. I can go ahead and box my x is equal to 9. I kind of jumped the gun. But I can go ahead and box that. That solution will work. Now I have to check my other solution. So I plug in 0 into my original equation. Well, that becomes the square root of 16 plus 0 minus 4. Well, square root of 16 is 4. 0 minus 4 is equal to negative 4. So my answer didn't work. So I would cross out my equal sign and say x does not equal to 0. Or if you're feeling particularly fancy in the moment, you can write x equals 0 as an extraneous solution. Whatever you need to do to tell yourself or to tell me that that does not work. Even though we did all the steps right, there wasn't any errors along the way. It just simply that did not work when we were dealing with square roots. Solving a cube root. Very similar process. I want to get the cube root by itself, but now to undo the cube root, well, I have to cube both sides. Then I'll be left with x minus 2 is equal to negative 8. Add 2 to both sides, I will get x is equal to negative 6. And now I'm going to check my answer just like we've been doing with the square roots. I plug my negative 6 into the x of the original equation, so I get that negative 6 minus 2 cube root plus 1 hopefully is equal to negative 1. Negative 6 minus 2 gets me negative 8. Cube root of negative 8 is negative 2. Negative 2 plus 1 is negative 1. And my answer works, so I can go ahead and box my solution. Now, a little bit of a secret about cube roots. If you are doing your problem-solving process correctly, you don't really need to check it. You're never going to have a cube root problem where you go ahead and solve it, everything works, and then you get your answer, you check it, and it doesn't work. So that is very, very, very true of square roots. You always, always, always need to check your answer, where with cube roots, you don't really need to check an answer. Always it's a good idea to check a math question, check your answers for a math question, not necessary for a cube root. So this next problem, I guess we have a lingering error. I'll probably see you in a while. This is, I've taught this class a few times. I have never seen anything like this on a test because it's a very difficult problem and it has a lot of steps to go through, so it would just take too much time on a test. Obviously, I can't predict the future, and I don't write your tests. My course captain writes them. So there is a very, 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 very small shot it will show up. And if it does show up, I'll tell everyone and say, go back to that crazy challenge problem I did. And I think there is one problem on the homework. But all of that aside, I don't think you'll see this one again. And so I'm going to go through it. I'm going to go through it fairly quickly because it is going to take up the entirety of the slide all the way down for the single problem. But I'm not going to break down every single step as that I have done on every other example, and I will likely do that on the future. So if you like challenging questions and you like very difficult problems, this is the problem for you. Follow along. If you kind of want to just track on what we've been doing in this section and maybe you're already struggling with, maybe just even skip through this slide so that you don't get overwhelmed, because it is a very overwhelming problem. Okay, disclaimer out of the way. Let's get to it. Now I have 2 square roots, so I can't really just isolate the square root because there is not a single square root. So instead, just pick one. So I think I picked, I isolated my square root of 3x plus 7, so I moved my square root to the other side. Next step, same as the previous ones, I square both sides. But now I have to FOIL a square root, which is kind of difficult to do as far as the concept goes, but it's the same exact concept. If you're doing FOILing, you multiply the first term by the first term, and the first term by the second term and the second. Anyways, when you FOIL it out, this is what it becomes. So that gets rid of this square. If I square that square root on the very right side of that expression, I get x plus 2. And now that I've gotten that scary FOILing with the radical out of the way, well, I can just move everything to one side again, and then I restart my problem as though it was not a terrifying problem. So that's all those 5 steps we're doing, is moving after I squared that x plus 2 on the right side of that 5th line. Every other step outside of that was just moving everything to the other side. So I added 3 and then I moved the x over, then I moved the 3 over, then I divide by negative 2, and so I'm left with this. Well, again, I'm going to square both sides. So if I FOIL out my left side, I'll have x squared plus 4x plus 4 is equal to x plus 2. I subtract the x plus 2 over, I factor, I get x is equal to -2 and x is equal to -1. And I'm not going to write the checking because I just don't have space on the slide. But x equals -2 does work. That solution is correct. X equals -1 is not a solution. It's an extraneous solution. So I put a slash through the equal sign, and I'm done with it. And that's it for this lecture.